The next rule we have in calculus is called the quotient rule, which, of no surprise, is either how we derive things that are being divided. So when we are doing the quotient rule, we are looking at the derivative of a function divided by another function. So for example, we're looking at something like 10x plus 3 over x squared plus 7. Or we're going to put some trig in there. We could be looking at something like x squared divided by the sine of x. So something that looks like that. Now the quotient rule is a little less flexible than the product rule, and you'll kind of see as I explain it in symbols first. So the way that we derive a quotient, it's the bottom function times the derivative of the top function, so bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the original bottom squared. And that kind of wants to be a track that should be heading through your head as you do these. Bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. The reason that this is a little less flexible is because of the subtraction. If you don't start with the right function, if you don't start with bottom times the derivative of the top, your subtraction is going to be in the wrong order and it's going to make your answer the opposite sign that it's supposed to be. So instead of getting something like maybe 3 for the slope, you'd get -3. And you also have to watch the denominator. The denominator is the original function squared. So again, bottom times over the top minus top times over the bottom, all over the bottom squared. I promise the more you use it, the easier it will be to remember it. So for this first one, bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So let's talk about simplifying. What's the expectation? So the expectation for me, and what you'll see in a lot of like calculus tests or delta math, I need you to clean up the numerator because the numerator oftentimes, especially if it's very algebraic, is going to have a lot of distributing in like terms. What I don't need you to do is I don't need you to do anything to the bottom. You are perfectly fine to leave the bottom as a quantity in parentheses squared. So on the top, I'm just going to do a little scrap work up here. I'm going to distribute the 10, so I'm going to get 10x squared plus 70 minus, I'm going to distribute the 2x. I'm also going to distribute the minus sign as I distribute that 2x. So I'm going to get minus 20x squared and then a minus 6x. So my final answer, when I combine terms, I'm going to have a negative 10x squared, a negative 6x, and a positive 70 all over the quantity x squared plus 7 being squared. So again, you have a little more rigidness with the quotient rule. You also have a situation where not the product rule, when it's all algebraic, often you can avoid it. You can do things like distributing and foiling. With the quotient rule, there's a lot of times where there's no other way. You have to do a quotient rule. I have had students say, well, I'm just going to derive the top and derive the bottom. It does not work that way. You will not get the same equation. So you do have to use this rule with your division. So let me show you the one that has some trig in it. A lot of times students look at it and think, oh, it's trig, it's harder. I actually find the quotient rule trig ones to be a little easier because there's less simplifying. So bottom times the derivative of the top minus the top times the derivative of the bottom. Derivative of the bottom is cosine, all over the bottom squared. And again, you can leave it like this, so you have very little simplifying. The only thing I may recommend doing, just bring that 2x to the front. So you have 2x sine x minus x squared cosine x over the sine squared of x. And there is nothing I can simplify with that. None of them. Sometimes you look and see, does everything have a factor that can be canceled? We don't. So that is your final answer. So that's how your quotient rule works, as far as how do we actually go through and get the formula, and then how do we use the formula both with algebra and with trig and kind of a combination.